Right, so in this talk, we're gonna touch a little bit upon those three modules there, like so EctoQuery, EctoRepo, and EctoSchema. We're not gonna even talk about change set because we're only focusing on reads here, like we focus on optimization for reading queries in Ecto. And we're gonna talk a lot about, like mainly about EctoSQL, precise, more specifically about Ecto with Postgres. So, did I just trick everybody here into a 30 minutes talk about Postgres, faking it was an Ecto talk? In many ways, yes. In many ways, that's what's happening here. But I think that's a good thing, though. And the reason is that when you think about it, like one of the things that I love the most about Ecto is that unlike other libraries like Active Record or, God forbid, Hibernate for Java, it's very close to the database layer. Like when you do an Ecto query, you're pretty much doing a SQL query. So it's impossible to talk about Ecto optimizations without talking about SQL and their underlying database. And in this case, I'm going to focus a lot about Postgres, so we're going to talk about Postgres tonight. Right, so we start with the query plan, explain, analyze. I'm sure, like most of you here, like senior engineers know like what explain analyze is, but I'm just gonna do the do's and just give a little bit of an introduction. So explain analyze and the query plan. So the query plan is like the main thing we go to start looking into optimizing any query, because we need to understand what to optimize before we actually optimize anything, yeah? And explain analyze is actually not one command, but two SQL commands that we use to get the query plan, and based on that, do the decisions that we're going to make to optimize the queries like in a SQL database. So let's take this example. We have a simple Ecto query here that we basically is like selecting from the locations table, join on a provider. In this context, a location is like a venue, and the provider would be like a business. So we are like fetching on the locations and joining with the business that belongs to that location, yeah? To run the explain analyze, we can't do straight away on the Ecto query. So we need to, we need a way to get the actual SQL, the SQL statement. And if we run this code here, we're gonna basically execute the query, but Ecto has this very cool utility function that returns the SQL query, the underlying SQL from the database that's using, in this case Postgres, and you can get the SQL statement to run your explain and analyze on top of. So the output of that code would be something like that. To be fair, it wouldn't be that pretty, it would be like a little bit messy, but I trust everybody here is smart enough to figure out how to format the SQL statement. With the SQL statement, we can go straight away and run the explain analyze. And if you do that, what you're gonna get is the query plan. Awesome, good stuff, no? Yeah, not really. It actually, yeah, it's not very easy to parse, is it? So it's a huge blob of text. But luckily, we don't have, this actually makes some sense, but we don't actually need to understand how to interpret that, because especially like in bigger queries like that becomes like very messy. We have tools like Dillable that have a nice visualization for it. So you can just like, basically Dillable is like a web application that you can just like copy paste the explain analyze output, and it's gonna give you like this nice looking, pretty and colorful output right there. Yeah, so this is like the query plan. So when talking about the query plan, we start from can you see this thing? Yeah. You start from the bottom nodes. So on that query, querying from locations, joining with providers. You see that on the locations, it ran a sequential scan on the locations table and an index scan for the providers. And here on the top, it just merged everything together on the nested loop. That's basically what the database did to show you the query that you just ran. And it's much nicer, yeah, it's much easier to understand. Two important things when looking at the query plan is time that each one of the nodes took to run in comparison to the whole thing. So here we can see that this one here, the sequential scan, took 90% of the whole execution time of the whole query. And that's quite a lot. So that's a good indication. That's not like a one-to-one, but it's a good indication. It's like a hint that that's probably something you should look into. A better hint even is the, wait, it's not working anymore. What's happening here, man? All right. So a better hint is the amount of rows it removed from the sequential scan. So a sequential scan is basically the database going through each row of the table and getting each row, and it filtered out 99% of all of those rows, and just returned a very small subset of that row. So that's a good indicator that you can use an index there. And if you use an index there, you're gonna speed up you might speed up things quite a lot. Talking about indexes. So indexes are probably the one most simple yet powerful thing that you can do in your database, a well-made index, of course, to speed up your queries, like if you know what you're doing. And I want to, I'm sure that most of the people here used indexes before, but I want to go one step deeper and try to make it very clear how they work and what are the limitations of indexes. So let's take this example with the services table. So services in this context is basically services of a beauty salon or a barber shop for no particular reason. And so we have like this table, service table, where we have like the name of the service, business ID, and the price. And we're going to create an index that looks like that. So it's a simple index on the service table that is indexing the business ID. So how does that look? So before I show how that looks, when you create an index by default with Postgres, it's going to create a B3 indexes. Postgres has several different kinds of indexes, like we have hash indexes, like geospatial indexes. In this talk, we're going to focus on the B3 indexes because they are the most common use case that most of the people use, and they cover most of the common cases that we use on the day-to-day life. So when you run this on this migration, this Ecto migration on your system, Postgres is going to create an index that looks something like that. So that's like a simplified version of the B3 from that table that the Postgres would create. And there are a few important aspects that I want you to understand before I move on about how this index works, about how this B3 works actually. So the first one is that you can see the index keys, they are ordered in an ascending way. So they are ordered in an ascending way, not only across each page, but between the pages itself. So here, 432, and you see there is ascending order on them, and that's the default when you create a simple index like that. Another important thing is that the references to the rows itself, they are held by the leaf pages on the bottom here, and the branch pages, they are used to traverse the tree. So, and another one is that the tree is balanced. That means that the amount, the number of branches between the root and the leaves are going to be the same no matter the leaf. So the lookup time is going to be the same from whatever key you're looking into. Right, so let's see how that works in practice. So we have our index, that's how the visualization works, and we're gonna see how it looks from that simple query right here. So we're querying by services, where business ID equal 49. Okay, so now I'm gonna need everybody to pay attention because I'm gonna make a very elaborated point to make a very elaborated explanation to make a very simple point. So bear with me, let's do it together. So how does it work? So I have my query here, query by business ID 49. The index lookup is going to start from the root, and from the leftmost, the smallest value of the root, and it's going to check, is 49 equals 4? No. Move to the right. The right is the last key of the page. So it already descends to the child page. Is 49 equal 32? No. Move to the right. Is 49 equal 43? No. Move to the right. Is 49 equal 49? Yes. So you should go down here, yeah? No, not really. Why? Because it knows that the next child is going to be a leaf node, and there might be some leftover keys on the leaf nodes here. So instead of like descending straight away when it finds like the first match, it descends from the previous match and go down here to the previous child, or previous leaf child, and it's gonna do the checking again. And now it's gonna do the checking like only horizontally, because it doesn't have to. It knows that there are leaves, so there is no more like pages here. Only the reference to the table. Comes here, 49 equals to 43. No. Go to the right. 49 equals 49. Yes. Holds the reference, so it holds the reference in memory. Next one, 49 equals 49, yes. Holds the reference to the table, to the row. 49 equals 62, no. So it knows that only by the ordering of the indexes, know that those are the only two rows that you are caring about here, and those are the ones that it's going to give you the reference back. And just one detail I forgot to mention, that the reason why you have like two repeated 49s in this index here is because it's not a unique index. So it's like a simple index, not unique, so it holds like the keys from they can be repeated. Okay, so let's look into another example about inequality. So before you're like checking for equality on the 49, now we're going to look for inequality on the 32. The business idea is 32. The descending until the leaf node, the leaf pages, they're pretty much the same. The difference is when it gets to the leaf nodes, man, this thing's not working every time. When it gets to the leaf node, it checks like it found like a match. Yes, it found a match for 32, and because this is lesser than equal the ID that you passed, it knows that it should look all the way to the left. If it were greater than or equal, it knew that it would go all the way to the right and just swipe the whole like thing, because they are linked not only like by descendants, but they are linked bidirectionally between each other. All right, we're almost there. So now we have the same table, like the same services table, but I'm introducing two more columns now. One is the price and the service type. And let's try to make a compound index this time, not the simple one, but a compound index. When you do that, we're going to have something like this. So this is like how it looks like. And what I want you to pay attention here is the order. So you see, like it first is going to order by the service type, which was the first column that you described in the index creation, and only then is going to order by the price. So yeah, it's not working anymore. So the service types, they are ordered among each other, and if you check the leaf nodes, you can see that the prices, they are ordered on the scope of the first order, which was the service type. And if you run a query on this one here, let's first run a simple one on the service type. It's going to do something like that. So again, same stuff. Service type equal 2. Is service type equal 1? Is 2 equal 1? No. Go to the right. Is service type equal 2? Yes. Go to descend to the previous one, because there might be something left over there. Is service type equal 1, 1? No. Right? Equal 2? Yes. Equal 2? Yes. Equal 2? Yes. Then you're gonna swipe until it finds the 3 that knows that's not equal, so it knows that those are the reference that it should hold and give it back to you. And if we do another example now, adding the other column, the second column that we have in the index, which is the price, it's going to do something similar, but it's going to stop. So the price is less than 400. So it's going to find all the leaf pages which have the reference to 2 and the price under 40. So that makes sense, yeah? And let's see how it works when you try to do only for the price now. Like we're going to only check the price and check for the prices that are higher than 300. How would that look? It doesn't really know what to do. And why is that? Because if you follow if you remember that the way the indexes work is by the order, like the order of the index is the thing that makes it so efficient. When it tries to run the algorithm on with the 300, that's like the second ordering, it might miss one of the previous ones because the previous one, the first order is going to be on the service type, and the second one is going to be on the price. And to be fair, if you run this query on a real case scenario, it might still use the index, but it wouldn't use an index scheme. It would probably use a full index scheme, which means that it's going to take all the values of the index. It's only going to use the index to gather all the values to memory and look through every entry to make sure it found the ones you want, and it's not as efficient. So that's the elaborated point that I wanted to make, that when you're creating indexes, the order of the columns, they are of the utmost most important. So if you're creating those two indexes here, the index itself, the tree, is going to be different, and they're not going to be the way you build your queries. You need to take that into consideration if you want to use the indexes. Yeah, and yeah, now I want to show another thing that Postgres supports, and Ecto has also like a good support for it, like pretty similar as you can see, which is include. So you can actually include values to your index, and when you do that, it's going to look like something like that. So your index, this data structure that you have, that you hold like that you hold separately from your table, is going to hold not only the lookup values, but also some values for reference. And when you do that, if you query only if you select only the values that you are in your index, you can achieve an index-only scheme, which is basically, so this is something I forgot to explain. So if you have an index scheme, which was like basically looking up the index key and then going to the table, the database performs two read operations. Yeah, one to look up on the index and another one to go to the table itself and fetch the values. If you do this, what you achieve is you have like all your data on the index itself. So whenever you do a lookup, selecting only by those values, you're gonna do an index-only scheme, which is much faster because it doesn't have to go to the table at all to get information. You can basically just get all the information from the index itself, and as you can see by the query plan there, like it's considerably faster from the index scan, and it can be very helpful in some cases where you need really optimized queries and with very little data. Oh, I need some more water, wait. Right, so let's talk about some caveats. Some caveats about indexes are, the bigger the index, the longer it's going to take to write, because index is a separate data structure that you have on your database. So whenever you add another write, whenever you make an update or like insert to your table, you're going to have to rebalance the whole tree. So if your index is pretty big, your writes are going to be slower. So you need to take that in consideration, because if it's a write-heavy table, you might slow things up in the end, and you need to consider the trade-offs. The bigger the table is, the longer it takes to create an index. Because same reasons, like the index is basically a tree of the keys that you define. If the table is huge, it's going to be a huge tree, and the building of the index might take a while. Something that's taking on that lead, when you create your dropping indexes, the database, Postgres actually by default, it locks the whole table for writing operations. So if you try to write something to your database while the index is being created, so you have a migration, you run trying to create your index, and you don't do anything about it, Postgres is going to lock your table, and if the index is big enough, it might take a while, so it might block your writes, it might block your users, and might lead to a bad user experience. You can go around that by using the concurrently option when creating an index. That's going to create the index concurrently, making the writes operations not a problem. But we have some caveats of the caveats, which are like if you try to write your index concurrently, actually not only for like Elixir context, but if you go to the Postgres documentation, there are a bunch of like caveats about that, like of things that you should take care of. So go through the documentation, get acquainted on that. On Ecto itself and on Elixir, like mostly Ecto, using concurrently doesn't go well with Ecto transactions. With Ecto transactions in the Ecto migration transactions, so it doesn't really work. If you try to create an index concurrently on a migration, Ecto is going to complain it's not going to work properly. You can work around that as well by disabling the DDL transaction and migration logs on that specific migration. The cost of that is though that you're going to lose all the transaction property of the migration, which means that each operation is going to be independently, and if you try to roll back, they're going to do it independently and might lead to problems. So if you do that, try to keep as short as possible, possibly only doing the index itself, because it might be dangerous otherwise. Right, so now that we talked about indexes a lot, let's go a little bit on querying. So we just learned how to do index-only scans, and I don't want anybody to miss on the index-only scans that we just talked about. And yeah, I just want to go over like kind of a little tip on just to be aware of more than anything. So let's say you have this schema, right? This table, reviews table, is like a simple table, some fields, you have like some foreign keys, and you're going to build an index including, like using the include option that I just described, with the including text and author name. And the index is going to be by location ID and rating. So in this context, a reviews like a reviews of a venue again, and the locations are like only the locations of a business. If you try to do something like that, like in just query like straight away from the reviews, like using a simple where clause, you might think that you're going to use your index-only scan, but actually no. And the reason why is, when you do that, you are underlying, like Ecto is doing like a select star. So it's selecting all the fields from that table, and the index-only scan only works if you're selecting only the fields that you need to select from that are holding on the index. So, and that's a very easy pitfall to fall on, because usually like the queries are not like as simple as that. It's like a bunch of functions composing each other, so it might be very easy to forget about writing a select statement. And yeah, and the solution for that, you're going to get only an index scan, and the solution for that is just writing a select statement with text, with the values that you have on your index that you just created, that you included on your index. And if you do that, the underlying SQL statement is going to be something like this, which selects only the values that are on your index, and you're going to get an index-only scan, which is pretty good, no? And now for my last thing I want to talk about. It's not really related to index, but I think it's a fairly cool feature that a lot of people might overlook on SQL, which are lateral joins. And for that, let's think of an example. Imagine that your product manager comes to you and asks for a feature. So he asks for, it asks for something like, let's implement an API that returns location by type with the top 3 reviews of each location. So in that context, what do I mean by location and about reviews? So locations, again, like venues. You think about locations, think about venues. So the contract would look something like that. So get locations by type with top reviews, return having the location type as a parameter, and the return type would be something like that. So Each location, like that would be a list, but it didn't fit on the screen, so imagine that there are several of those. Like it's going to be a list of those locations which are in one table, and they're joining top reviews in a different tables, and you only want the top 3 ones. So it's like the limit is a factor, yeah? If you're going for something like that, you might instinctively go for like, okay, like I need to get top 3 from like all the locations, so I'm going to have my API, something like this. So we have like a function here that's querying all the locations by the type, and then we are running over each type, and then querying the reviews on each location for that type, limiting by 3 the top 3 ones by each location. That would work, of course, it's not going to fail or anything, but the problem here is that depending on how much the result set from the locations would be, you would be running a lot of subqueries, like the review queries, on your location. So imagine, I don't know, it's like a huge number, like say 100,000. You're gonna run 100,000 other queries, like inner queries, on the outer one, and those outer queries are gonna have not only like the cost of the query itself, but all the throughput, like all the round trip cost through the other service where the database is, and all of that. And there is a way out of that, which are lateral joins. That's basically a cool feature from Postgres and maybe some other database that I'm not aware, but Postgres for sure. And Ecto has excellent support for it, where you basically write that statement there, inner or lateral join. And if you do that, and you have a subquery with like basically exact same SQL statement as before, what Postgres is going to do is going to run on each element, on each row returned by the outer query, is going to run your subquery like by basically each row on the outer one. So that's kind of a loop, like a looping through like the queries on the SQL level. So you do in one SQL statement, you get all the data you need. Sorry. And if you look at the query plan, you see, like you can see very clearly here, like, so this is the query plan for the previous SQL statement that I just showed. And you have like a sequential scan, like on the locations table, and index only scan on the reviews one, and by the, it's not working for sure. And by the number of rows returned on the sequential scan, you can see 6,029. And you can see here on the number of loops returned by the index only scan is also 6,029, which means that it runs like it runs this query like over like the whole set of the outer one. Comparing that with the previous solution, which would be like two queries separately, you can see that the sequential scan didn't change that much, but the index only scan, that's an average that I took, like, so it's like one of the values, it might vary a little bit, but it's gonna run like around 0.2 milliseconds 6,000 times, because one time by each entry that you had on the outer query. And that might lead up like only the sum of the values is already much higher than the previous ones, like 1.2 seconds, plus the round trip cost, so like the going back and forth between services. So it might be a useful tool if you want to, if you have this use case, just something to keep in mind. And to wrap it up, yeah, everything depends. So I talked about a few things here, like about indexes a lot, about like other things on like query approaches. But in the end of the day, the best approach you can do to like optimize your queries and optimize your data model is optimize the end result for the customer is to understand your data model and your use case. Because even indexes can bite you in the ass if you don't know how to do them. Like if you have like a query that's gonna, like you have a table that's all the queries are gonna for sure run over the whole table. The index, probably Postgres would use like a sequential scan anyway, so it doesn't even make sense to have an index. So everything depends, like understanding the tools and understanding like what your user needs is the most powerful thing that you can use for your optimizing your queries and like application overall. And yeah, so those are a few references that I used to come up with this talk. I can forward to anybody later if you're interested. And that's it, thank you.
come up. Okay, cool. Awesome. Thank you, Felipe, for the enlightening talk. Do we have any questions for Felipe? Anybody?
Yeah, I did a very good job then. Nobody has any
Yeah,
questions.
you explained
I
everything
forgot to-
perfectly. Like, it's all clear now. I'm assuming like we can talk about that during networking as well.
Oh, there is one question over there.
Oh,
So firstly, thank you very for your amazing talk. I do have one question, and it relates to the lateral join that you presented. And my question, how does it relate to just like creating, a window over the whole set and just like ranking it and selecting by the, where the rank is higher than whatever we want? Is it any quicker, or do we gain something here, or is it just like a showcase here?
Yeah, so we were talking about denormalization, right? Like in some level. Yeah, that's the thing what like I mentioned when I said that I can understand the data module is like the best thing that you can do to optimize your queries. Like yes, denormalization is like a very useful tool, and can be more powerful depending on the context. On that, talking about lateral joins, like if you go very deep on how depending on the query, like the lateral join is just might be like a simpler way out to get like the same result. But if you realize that it's like a very big table and like the lateral joins taking too much time to run each query, you might go to this denormalization. And denormalization also adds another layer of complexity, because not as straightforward. You're basically taking your data that was like concise in one place in one table, and you're putting in another thing. So it adds to the cognitive load of whoever is going to look into that later. And you might go that way if that's like the approach. It might be better. But if you have like something else that you can try before going that far, it might be worth the try. So yeah, in the end, you could do that as well. It's like kind of interchangeable in a way. There are several ways to do it. It's mostly boils down to the developer what's the best case for that particular problem. Yeah, and I personally think that keeping it as simple as possible and less things for somebody new who's joining to think about, to understand about the context, that's better if you can do that. So yeah, I hope that answers your question.
Okay, thank you. So the answer is it depends.
Exactly.
awesome. Thanks. Any other questions? No. Yes? Oh, Carol.
Can you recommend any tooling for detecting slow queries on production, or how you actually attempt to debug slow queries when you have a running Elixir system and you just want to quickly see what's going on? I think that converting it into SQL and playing with raw SQL, I don't know if it's like the most efficient thing to do, or do you have anything better?
I mean, usually that guy over there just screams at me and say man, this thing's too slow, I need to do something about it. But yeah, you're right. We do have of course several metrics to at least how we do it fresh. Yeah, we have several metrics that show when something is not fast enough. We have these graphs in Datadogs and whatnot, the monitoring things.
In Datadog, right?
Yeah, so we use Datadog. So basically, I wouldn't know to tell you this tool that you're gonna use to profile your whole application and get all the queries, because one thing that actually I forgot to mention is that when the query plane and all of the how the query is executed, it depends a lot on the real life scenario. So unless you have real life data and real usage, it's very tricky for you to understand what's fast and what's slow. So on a high level, what I can tell you, you have some monitoring, and if something is too slow or to taking too much time, timing out or whatever, you're gonna have some monitoring popping up, and then you're gonna look okay, so it's popping up on this function right here, so what's going on? So it's not we're gonna go on every single query and explain, analyze every single one of them. It's mostly seeing when the problem arrives, or when you're implementing, trying to test something, if you know that potentially can be like a performance pitfall, trying to check that against a production environment and taking your extra time to take a look at performance before you just like implement the feature, see if it works with, I don't know, like 20 rows in the database, and when you have like 2 million, it's gonna see it might be a problem. So thinking like testing against like real case scenarios and like understanding that is one thing, and monitoring, like seeing like when your alerts like things are too slow popping up, and just being mindful of that and like looking into exactly what the problem is. I think those are like the best tools. Maybe there is something else. Honestly, I wouldn't know like if there is like something that just runs over like every case, but that's like how we usually do it, and that's how I personally do it.
There's a plugin that you can add that automatically logs the explain of the query that is slower or without threshold.
Is there? Are you asking or you refer me?
There is an assertion. There is.
Okay, good. So you can ask that guy. Emiliano knows.
Yeah, and another thing that has proven useful for strategy that has proven useful for me recently was logging into a running container, logging to IEX console, and just patching some production code to inspect some queries.
That's hardcore.
So then, yes, it may be, but depends.
Like, of course.
The nice thing is that you don't actually have to convert query to SQL to see the explain, because somewhere in Ecto SQL module you also have explain method that takes query directly. So it's just about putting query in.
I didn't know that. That's cool. I had no idea.
Yeah. So you can just produce explain right from Ecto, and then log it, for instance, to some logs and take a look at it.
Everybody forget about the first part of the talk. Like, let's do that instead.
Sorry.
No, that's good, man. Like,
Thank
I didn't know that. Like, thank you for sharing.
Awesome. Let's not patch things in production.
Yeah.
I disallow it.
Yeah. I'm not allowed to.
Okay.
My CTO is not here.
Slow query log is for help.
Slow query log.
On Postgres, you enable slow query log
Yeah.
and specify, for instance, 500 milliseconds, and all queries that take
You're going to be logged.
will log. Yeah. And also you can take a look at guest statements.
Yeah, cool.
It's extension.
This extension.
Awesome. Cool. Awesome. Thanks for the feedback. Cool. I think we'll be wrapping up. So if you have any other questions to Filipe, we can take it later, because we still have our guest of honor, Jose, and we wanted to do the Q&A session. So let's just, before we jump into that, let's have another round of applause for Filipe.